So this is the first of 3 videos that I'm going to make on integration in calculus and sort of explaining what integration is all about. This one I'm just going to talk about the sort of fundamental problem that we're addressing with integration, which is called the area problem. And the area problem is basically how to find the area underneath a curve. And we say underneath a curve, what we really mean is between a curve and the x-axis. So the area problem is something like this. You can imagine I've got a line. All right, so this is my graph f of x, and I'm trying to find the area underneath the curve, or rather between the line f of x and the x-axis, between 2 points A and B. Okay, well in this case, so I've drawn it here, it's a pretty simple problem. It's just, you know, you've got a width here, let me use a different color, or you've got a width here, we've got a height here, right, and we know that the area in this space here is just going to be the width times the height, because it's a rectangle, and that's really easy. Okay. It can get a little more complicated. We can imagine that we have something more like this, right? And now we've got maybe a f of x is still a line, but it's a slanted line, right? Okay, now we're trying to find the area under the curve, between the curve and the x-axis, between 2 x values, a and b. Now this is still a fairly straightforward problem. Like you've got a trapezoid, or to be honest, I don't really like trapezoids, so I usually think of it as like a rectangle, and then I think of it as a triangle, and that's some simple geometry, right? This area is going to be the width times the height of this rectangle. This area is a triangle, so it's 1/2 of the width times the height of the triangle. Not a problem. I add those up, I've got my area. Okay. So that's easy, and this so far requires no calculus. Where do we have calculus come in? Okay, well that's going to come in. We've got, and probably see this coming, well we've got something like this. So here instead of a straight line, I've got something like, ooh, fancy, yeah, and this is my f of x now. And I want to know the area underneath the curve, f of x, between the curve f of x and the x-axis, between, say, here at A and here at B. Now, there's no simple geometry that's going to allow me to figure out what this area is. It's a wonky at the top. I could kind of approximate it, and we can talk about different ways to approximate it, but the basic thing is I'm not going to be able to just find the area. The only way for us to find the exact area, not just approximated, is going to be using calculus, and specifically using integration. And that's what integration was invented to solve, was to solve this sort of area problem.